Yeah, okay, great. Well, thank you for attending. Thank you also for tearing yourself away from lunch. My name is Nick. I am a software engineer for IBM. I'm here today as my capacity as a maintainer for Hyperledger Caliper. I'm going to be a bit strange now, and I'm going to close off the slides at the very first point now, because I'm going to disappear to our GitHub branches, and I'm just going to quickly kick off a release. So I'm definitely going to approve that. And press the big green button and confirm. Okay, so now I can go back to the presentation, because at the moment I've just pressed the merge button on a pull request, which ultimately is going to end up in releasing Caliper 030. And this presentation is about everything that's in that release. So what am I going to talk about? Well, I'm going to be talking a lot about Caliper. I'm going to give an overview. Then I'm going to move on to the supported technologies. I'm going to touch on the concepts that Caliper uses, speak on the operational modes of Caliper. Then I'm going to move on to the other end, right off the end result of Caliper. That is, it's the report generation, and it's all about performance tests and results. If it's possible, a quick show of hands. Has anybody used Caliper before? 1, 2, yep, 3. Okay. Has people heard of Caliper? Anyone? This is completely fresh. What's possible here? Okay. So a good mix. Great. Okay. So, well, Hyperledger Caliper, it is a blockchain performance testing framework, and that allows you to test different blockchain solutions with predefined use cases. We're not bound to a single technology. The idea is that you can transfer across the same scenario tests to different DLT technologies. And you can run the same predefined use case, and at the end of that, you'll get a generated performance report for the test case that you have run. And in that report, you'll have details on the transaction success or fail count, the transaction throughput, that's a TPS, or transactions per second, transaction latency, how long one of these transactions took to complete, and we're also detailing resource consumption, so how much CPU is being consumed, how much memory you're using, the network I/O, the disk I/O, so you can see at different points of constraints for the system you're looking at. And that's probably the highest level takeaway for this presentation. So Caliper is about testing multiple frameworks, generating reports on transaction statistics and resource consumption. So why would you want this? Why would you use it? What could you use it for? So you can use it or view it for use on different planes. So if you're an application developer, you may want to performance test your smart contract. So you've been through the development cycle, you have a solution, how performant is it? You may be a system architect. You may be looking at where your resources are being used, where you want to spend the money. So you'll be looking more at the resource constraints during a test load. Or, hopefully, you're interested in performance regression testing. So back up the chain again, you are the application developer, perhaps. So you've got your solution, and you're iterating your solution, and you're making sure that you're only getting better transaction statistics, you're only going faster, your throughput's greater, your latencies are lower. Or, flipping that around, you might be a fabric developer, a Corda developer, well, not Corda, not yet, spoilers, say Ethereum, Besu, Sawtooth, and you might be changing the platform code. If you're working in Fabric, you might be changing the core code inside Fabric. If you're an SDK developer, you might be changing the way that eventing works. At that case, you can fix your smart contract, you vary the code under test, and you can check those changes instead. So you can see it as being able to performance test your smart contract logic. You can see it as being able to performance test a change in the actual platform as well. Okay, where can we get this? So Hyperledger Caliper is available as NPM packages and Docker images, or if you want to, you can just go grab the source code from GitHub. Don't worry necessarily if you want the latest and greatest source code, well, so the most recent unstable source code. We actually publish on NPM and Docker for every merge. So every time we accept a PR, we will build that in and publish at an unstable tag, so you can get that instantly. And when we feel we've sufficiently broken the original implementation, or we are sufficiently feature complete, that we'll tag an official release level. On NPM, we're around about 2,500 downloads, and Docker Hub, we've got about 1,000 pulls. So we are getting there. And when you're using Caliper, it's mainly driven via command line interface at the moment. Big shout out to Jason here at the moment. If you were at his presentation earlier, he's been putting together a GUI in front of this, which just makes everything so much easier to consume. So looking at our supported technologies, we're adapter-based. There's no real limit on the technologies we can consume or map to. At the moment, we are able to run a performance test on Besu, Burrow, Fabric, Iroha, Sawtooth. Those are Hyperledger items. And we're also supporting Ethereum and Fisco BCOS. So those are our currently supported items. And we would be happy to grow those as well. So if somebody was to come and approach us, say, hey, you know, I want to follow your interface for the adapter so we can target this blockchain technology, great. Yeah, we are very welcoming to PRs. We are very welcome to new adapters for new technologies. It helps us, it helps you. You know, if you can use the code that gives you the ability to run performance tests, we are more than happy to help with that. So, concepts. What does Caliper use? So, we have a network definition. So this is the definition of our target blockchain technology, and it's any one of those supported platforms. So we're defining our network, and then we'll have a series of smart contracts. This is it's the logic that you have developed as a developer. It governs the life cycle of the assets being modeled within this target blockchain technology. These are generally bound together. This is not a strictly necessary part, because we'll need this if we want to stand the network up itself. So we'll be standing your network up, deploying your smart contracts. That's an optional stage. The less optional stages, or concepts, is a test definition. So we define the way methods are available in smart contracts. So if you're thinking in Fabric, you're going to be submitting specific transactions which target a method you have defined. So, well, Caliper needs to know how to deal with this. So we'll have a test definition file, we call it a benchmark, and a benchmark file, and it's really a sequenced list of events. So you can consider it as the flow for the test being run. And this will be, let's say, let's consider we're testing creation of assets. You may have a series of tests you want to run where you change the size of the asset being created or the content of the asset being created. And you're going to be saying how you'd like that to be controlled. So what rate do you want to be driving the test at? How long you want the test to be run for? Are you running this for a series of discrete transactions, or are you running this for a time duration? So you can see it as the entire control flow for the output benchmark you're running, and this still calls into test libraries. Now, we give you absolute control over this aspect, so you could probably think of Caliper or consider Caliper as a bit of a dummy item that just sends transactions. And it's up to you, the user, to tell Caliper what is the content of that transaction. So again, if we consider the creating an assets scenario, it may be that inside your user module, you have the logic that's required to populate the information that's going into that asset. That is entirely up to you. It's very easy to configure. I would say it's quite easy to configure because I'm stood here and I've used Caliper for quite a while. But yeah, essentially you define the transaction content going through. And what does Caliper do? So Caliper takes these items, it takes the network, it takes the libraries and your test definitions, and it will then run through the test definition targeting these user modules. And once it's completed this, it's going to generate a result. So because we are running each transaction, we're monitoring what goes on, and we're going to be taking transaction statistics. So a point to note is that the transaction statistics themselves, these are taken from the reference points of the driving SDK. So if you're considering the transaction latency, it's from the point at which the SDK has submitted a transaction to when it comes all the way back around and it is complete again. And the same for the throughput. So we're not measuring on the DLT itself, it's as observed from the client side. Now, I've been talking a lot about these generated results. So we collect those, but we're also collecting resource statistics. And these can be done through the most simplistic way, which is Docker stats. That's our default option. Or you can go a little bit further. You can use Prometheus with custom queries. So we integrate with Prometheus, and as soon as you do that, you have availability of quite a few scrape targets. And then you have the other options of looking at things in real time with Grafana. So operational modes. Default option for Caliper would be, say you use the CLI command, and it's essentially run the test. But if you want, you can break this down in the phases. So Caliper would normally start up, it would initialize, so that would be the standing up the network, deploying the smart contracts, and then we run a test, and then you do an end, which is the teardown situation. Now, it may be you want to do a skip or an only on any one of these options, so you might want to only start, only initialize, and then you could do a sequence of only test. So that maintains the state of the DLT, and you can spin these tests over and over and over. Or it might be that you don't want Caliper to stand up your network. You have your own processes that do this. You may have a whole load of scripting. You might be using playbooks. You might have a system that's already been configured for you, and all you want to do is test it. That's fine. You can grab the credentials from the system, pass them to Caliper, and do an only test kind of operation. If someone else has set up the network, you probably don't want to do the end section. But if you do the only tests, you drive your workload, you get your results, and you can investigate from there. So one of the main things that's in our current release that's possibly built by now, hopefully. I think I might have cursed myself doing it live. So we have kind of these modes which are local or distributed. There's also hybrid. So the local mode is exactly that. Everything is running on the system where you've installed Caliper. All the containers will be there. We'll spawn processes inside that same system to target the DLT. And we use the locally based resource monitoring tools. So yeah, everything is very much contained Distributed is the absolute opposite of that. It will be where you have a remote DLT, you have remote Caliper clients driving a workload. You'll have a manager-style, a manager-style Caliper operation, which is coordinating the workers, collecting the results, and assembling a report. And then you've got the hybrid style there, and perhaps you don't want one aspect of the local system. That's fine. So you can delegate off the resource monitoring to Prometheus and its scrape targets. You can then move out your workers to be distributed as well. And I think that kind of follows relatively nicely the development cycle. Start local, go distributed. So we enable you to do exactly that, prototype locally, and then move on to a large-scale distributed system when you're ready. And of course, you can bridge that gap in your own time. I'm going to apologize in advance for the next slide. If any of you are playing presentation bingo, you're about to be able to tick off the unnecessarily complicated diagram that might be around available. But this is how Caliper looks if you're working in a non-distributed mode. And if we start on the left, top corner, we have our configuration. Mentioned it before. We've got our network definition, our smart contracts, the test definition, and the test modules. These are your parts that you need to feed Caliper. And when that comes through into the master, we have an optional admin worker, and that works through an adapter to configure the system under test, possibly stand it up as well. And then we have a worker orchestrator that spawns multiple workers. Now, each of these workers are rate controlled through an adapter, and that's producing the workload. As the workers operate, they're publishing their transaction statistics to a performance analyzer. At the same time, there is a local resource monitor that is running. And when the test cycle is complete, it passes all this information through a report generator, and you get your test report. So if you run that locally, so if I was to run that on my Mac, the results are quite low, quite obviously, because it's on one system, CPU constrained, and at some points, not many people run their production system on a local PC. So you want to start moving towards this distributed realm. So let's look at the hybrid. We still have our configuration on the top left, and we still have the Caliper master, which has an admin worker and a worker orchestrator spawning local clients. The difference now is that we've got Prometheus in the mix. So Prometheus, if you're not familiar with it, is a very useful tool for collecting, information, really. So we can publish worker statistics through to Prometheus, and we can use external resource monitors, say cAdvisor, Node Exporter, to collect information from the system under test. That's all coming through to Prometheus, which is being held inside the Prometheus containers and on its own database store. And then we retrieve all that information from Prometheus. So we're still using the local driving clients, but we've delegated resource collection elsewhere. And that then comes through our report generator, and we get our test report out the other side. So next step would be to move the workers outside, and we can do that. So we still have our network definition, the smart contracts, the test definitions, and the test modules. There's the option for the admin worker inside our master process to configure the system under test, but we have our workers external now. So we have these the workers, they can be on any system. Will be as Docker containers, so you can scale these up to your heart's content. But they're still working exactly the same way. They're still rate controlled through an adapter targeting a specific system under test. And they're still publishing to Prometheus, and Prometheus is still taking additional details from any resource monitors you've configured. And then this is run through our same report generator to gather a report. So there's a kind of a very blocky kind of description. So if I flip across to a slightly more concrete example, and this is how it would look if, like I do, I test Fabric quite a bit. So if you were to use this in a distributed fashion, so each one of these little container shapes, that's a Docker container. And again, we've still got our configuration files. That's absolutely unchanged. But we've stood up our master process as a container. And it's talking to our distributed set of workers via MQTT. These workers are using the push gateway to Prometheus. Prometheus is also targeting a C advisor and node monitor scrape targets. It's pulling information from the peers themselves because Fabric is able to export metrics. And the Caliper master as well as communicating via the workers, which help us orchestrate the entire test flow. And it can then drag in the information it needs from Prometheus to generate our test reports. So that would be a very concrete kind of view of how you could configure Caliper to work. And you can imagine, this could work in Kubernetes, so or in a Docker Swarm kind of scenario. So again, we can move from a local laptop running on your Mac up to something suitable for enterprise level testing. So what do? Caliper exports certain items to Prometheus so that we can retrieve them later. We send out TPS, the latency, and our success and fail count. So this is per worker, and we can then run queries on these to aggregate results to pull into the reports. What we do is we use the worker orchestrator to essentially walk through your test definition. So the benchmark configuration file you have, we'll step through that. We'll make sure that each worker is kept in sequence, or they're all operating at the same time. And between each round, the worker orchestrator will issue time-bounded queries for the Caliper statistics. So these are what you get by default every time you run a test. But what we also let you do is run custom queries. So, okay, that's quite handy, I believe. So you're always going to get your TPS, your latencies, success and fail. But you've been configuring, or you have the option to configure additional resource monitors, for instance, C advisor. And what that then gives us the ability to do is say, okay, yeah, sure, you're going to get a certain number of things for free. If you want something else inside your report, tell us what it is. Okay? It's entirely up to you what you configure. It's entirely up to you what you ask the report to contain. And we're not going to tell you what that should be because it's your system. It's the information you want, so you tell us that. And essentially, if you can run a Prometheus query and retrieve that information, then just put it in as you would. Basically, tell Caliper the query you want to run, what you're calling it, and in the instance here, I've run a query saying, I'm interested in the maximum memory consumed during each test within the entire test definition, but I want megabytes. So we've got this notion of a multiplier because I know they're coming out in bytes. So there is a multiplier you can add in. I'd direct you to the documentation for this if you want to start using custom queries, because there is a fixed definition with fixed options, but it is highly flexible. So if there's any information that you're storing in Prometheus you want to pull out, we can do that for you. Yes?
Do you record transactions per second and the latency over time in the run, or is it just for the run?
So it's recorded through the entire run, and we'll do an aggregation, a time-bounded aggregation between whenever the test begins and ends. So you can also use.
Option of saying these many iterations per run and then aggregate all those iterations. There's both the options. One is time bound, the other
Yep.
one is number of iterations.
Number of iterations or number of transactions sent?
Yeah, sorry, number of.
Okay, yeah. So on that we cheat. So we say when does the test start? So the workers will be like, hey, I'm ready. Then there's an optional initialization phase, and they say, okay, I've initialized everything. And once all those workers have confirmed they are ready to go, the master will say, and go, and we take a time index. When all the workers have completed and come back, say, we're done, we take another time index. And so you will get the information aggregated between those two time points. And it's the workers themselves will either do a time-based run or a transaction-based run.
And if I want to grab the memory consumption over time, doesn't actually like the problem.
Yep.
How do I?
I'll show you that in a minute. Okay, so Fabric. I hinted to it earlier, or actually I mentioned it. So Fabric peer and order metrics are exported for consumption by Prometheus and Sysdig. There's a reference point there if you want to follow it. But that means that we can start pulling out exceptionally custom queries. So I'm only interested in Fabric things, but perhaps I'm interested in, this query here, which is pulling out the endorser proposal duration. It's quite a niche item to want to pull out. I might actually be interested in time spent in CouchDB. I might be interested in the time taken to commit. So all of those metrics are available. All those can be pulled out. You can create a custom query for that. Now I'm going to jump straight across to how would I see how it trends in time. So if you're using Prometheus, you can also use Grafana. And Grafana exposes everything that's stored inside Prometheus. So you can visualize the exported metrics. You can do that in real time, but you can also go back in history and see what is happening between a specific run or at a known time point. The item on the right is one of those, did you know there is a Grafana dashboard for Fabric? There it is. So yeah, it's the dashboard 10716. Just rolls off. It's easy to get. So that's Fabric 1.4x. But there are lots of dashboards. So on the bottom left, that is a Docker stats dashboard. Again, that just ties straight in, and you can have a deep dive and view metrics. You can also create your own custom queries inside Grafana to have a look at something that you want to see. And yeah. Definitely recommend having a look at Prometheus if you never used it, and hooking Grafana is exceptionally useful. We are intending to put together a Grafana dashboard for Caliper. Unfortunately, we just haven't quite got there yet, so it is in plan. So you'll be able to jump through tabs, and you'll be able to either, at the very least, you'll be seeing the TPS that Caliper's producing, or the Caliper is observing, and the latencies. So that will be something that is inbound. Okay, so I've spoken quite a bit about this so far, the way we are being able to set up a distributed system, and you can run your test and you get some results. But what do these results look like? You get a report generated for each test definition run. This is our new style of report, slightly shinier than it was before if you see the earlier ones. And there's only one test run here. So if you had a test definition which was running multiple tests, you would see a highlight on the very top indicating the number of success fails, the send rate, so that's what Caliper was sending, the observed actual TPS, and also the latencies. And then for each of these rounds, you'll get a slightly deeper dive. And you can see at the bottom, we've got the results of certain queries that were being run through Prometheus and the results of those queries. If you don't like looking at just numbers, it gets a bit dry, then sure, okay. We've added the option for graphical outputs, so you can have a quick glimpse view of where the expensive components are. So we do these radar charts, which are quite nice for visualizing, but we also do the bar charts if you're not a fan of radar charts. So that's kind of the outputs of Caliper. But how can you use this and where are we using this? So I'll move on to thoughts about performance testing. So maybe not everyone here is involved in performance testing or testing at all. So my view, it's a very personal view on performance testing, is that they should be directed. They should be focused on a specific aspect of the technology or an attribute of that aspect. More importantly, they need to be repeatable. So if you're publishing some results, then they need to be repeatable by somebody else. Okay, so you need to list the resources used to perform the tests, details of the machines, the configurations. So if you're saying, hey guys, I ran this test, this is what I saw. It's like, well, okay, what did you run it on? And what did you run? So, okay, we're talking here about making available your test definition with the test libraries and the systems you're running on, as well as the network definition. So all the things you fed through to Caliper, make those available as well, so this can be repeated. Final one, insightful. You should be trying to yield meaningful tests that are multidimensional. I'll come on to that in a moment. And yield tangible observations. So I guess I'll come on to this then. So, hey, did you know we publish performance results? Okay, so we do have a website where we are publishing performance results for technologies. And in particular, on one of those there we are publishing for is Fabric. So I will drop out of here, hop onto our slides. Okay, so this is our benchmarks repository. If you've been playing with Caliper before, you've probably come across this. But in here, we have provided benchmarks. So these are test definitions. We have the networks. So it's a pre-canned network you can stand up and run a test against. And we have the source code for the smart contracts to deploy. And we also have a website which is showing these results. So if we look into Fabric, okay, so again, this is another view of how Caliper is being run. So we're pushing our test files through into the benchmark engine, running that against the network. And these are the details of the smart contract. This particular test was not a scenario test. We are focusing in on specific aspects of what you can do inside Fabric. So we might not actually be doing anything. So if you have an empty contract, just returns instantly. As soon as it's invoked, it comes straight back. You may be creating a single asset. So you're creating something. So that's a put state operation. You might be creating multiple things inside a single transaction. So you're doing a batch kind of operation. You might be deleting something, or deleting in a batch, performing a get, performing a multiple series of gets inside a transaction, or you might be doing some kind of query. Maybe it's a range query or a rich query. And I've got some more definitions here, but most people will probably click straight away through onto the results. We've got results here for 140. Most people are like, hey, what's going on in V2? At the moment, for V2, the Node SDK is still in beta, so essentially these results are still in beta. But here's our configuration. So this is the machine configuration that was used. We're running these tests on RHEL system, and we're using the V2 images for Fabric and chaincode, but we're on a snapshotted version of the Fabric SDK. As soon as the official Node SDK is released, we will be repeating all of these tests and updating the documentation. So we have those for running an evaluate or a submit style query. Essentially, it's an ordered or unordered style operation. So yeah, I recommend checking those out. Worth bearing in mind, you can't really compare between V2 and V1.4 on here because it's using a different version of Caliper. It's using a different configuration, so different machines, and it's using the distributed setup rather than everything being local. We are interested in doing a stage compare, so the same Caliper system for all these different versions, mainly between the major releases. But yeah, we do have these results. I absolutely welcome you to have a look at them. And we'd also say, hey, if you really want to confirm these results, run them yourself. So we have the benchmarks. So it was an API test, which was for Fabric. And these are the configuration files. So these are the test modules that we're running. And this is the definition for each test that was run. So I believe I'm quite rapidly running out of time. So you cool down on a comic and open up for any questions that you may have. Yes?
My question about the monitoring. The monitoring can do the TPS latency and success and failure. So what is the failure status?
Oh, okay. So we will. Yep. So the question was, Caliper records TPS, latency, success and failure. What is this failure status? So if a transaction you submit fails, perhaps there's a timeout, or perhaps there is some other error within the transaction itself. It may be, say in the case of Fabric, there's an MVC conflict. Then that transaction is registered as a fail, and it doesn't complete successfully. So that would be recorded by Caliper as a failed transaction. Having a transaction fail is actually a very good use case. So you might actually be wanting to drive a specific percentage of failed transactions.
So the monitoring function can monitor the failure reason or not. The failure reason including the MVCP or transaction invalidity.
So you wouldn't get the reason come back inside the report, but you would have the reason inside the logs of the run. Sorry, the question was, would the report contain the same things? Yeah. So, I'll repeat your question. The question was, would you get the reason for the error inside the logs, inside the report? The answer is no, but you would have the reason coming out in any logs going on inside Caliper. So Caliper is able to, during the process, it will be logging either info, warning, error, logging. You could also look inside any of the other information, so you've got other logging tools available, which you would see that error. Okay, hi.
Can you specify how much
Okay, so the question is, can you specify a ramp-up period for workers? The answer is yes. So there is a modular controller we have. So everything in Caliper is based on modules. One of those modules is a rates controller. So you can have a fixed TPS, you can have an increasing TPS, you can have a TPS which is based on maintaining a specific backlog of transactions, or there's a modular controller. So you can piece together these particular controllers. So you could have, say, a low TPS, then jump up. And if you wanted, you could do a kind of a sawtooth motion or a stepped TPS. Hi.
Next up, follow-up for the failed transaction one. So that's actually a good point where if you want to cause your system to fail a certain amount of transactions.
Yep.
I recently was dealing with a bug in Socket where how failed transactions were being dealt with internally.
Yes, so the question is, how would you cause a transaction to fail? So yep, the answer there is we give you complete control inside the code you invoke. So you are in complete control of the body of the transaction. And if I was to do it, I would keep my logic there. So I would be purposefully sending through a set number of transactions I know will fail.
Do you have any way of, like, is that kind of the platform, because you probably think all of that, but causing a transaction to fail, right?
Inside the platform? Oh, sorry, the question is, sorry, what is the question?
So if I submit a transaction that is valid, it's going to fail.
Yeah.
What if I wanted to simulate some actual runtime failure or system failure inside the validator?
Okay, so the question is simulating a failure in the system under test.
This is kind of tricky.
Yeah. If you have the ability to change the code in the system under test, I'd be doing it there. So if you're building your own image.
I'm just saying it because it's a hard thing to do.
Yeah. I know systems before where where there is an operational mode, so you could send through a message. So we put the system into a particular test mode. You send through a message which contains a body that gets evaluated as it goes through the system, and when it hits the point, it will trigger an exception. But you need a lot of control in the system under test to do that. Cool. Oh, one last question.
So Prometheus queries that are executed in the local storage of Prometheus, or are they going directly to the ledger?
Okay, so the question relates to querying on Prometheus, and yes, so we go straight to Prometheus. We issue an actual Prometheus query against one of the APIs it has, depending on the type of query. We don't go to the ledger itself. It's to the Prometheus store.
Okay, so during the test, Prometheus gathers like a dump of the statistics, and then you query the Prometheus to...
Yes.
Is anybody interested in production like any network that's based on those frameworks?
So the question is, anyone using a Caliper in production? I don't know is the honest answer. I know people use it in proof of concept stage, and I know people have targeted large-scale systems, but I don't believe they've targeted something that's actually in production at the same time. It'd normally be a pre-production operation. Okay, well, thank you for listening, and have a nice day.